Welcome, everyone. Next up, we've got Gautam. He's got over a decade of experience creating customer-centric solutions across industries. He's a regional solutions engineer at Couchbase, and he's here to talk about leveraging Google Gemini and Couchbase Mobile for AI-driven edge. Give it up, Gautam.
Hello, everyone. Can you guys hear me? Okay, cool. Good morning. Thank you for coming over a weekend. Who is excited to be here on a weekend? Okay, at least a few. All right, and how many of you have heard about Couchbase before? Oh, there's one person. Fantastic. Now you know Couchbase is, widely known technology disrupting the world. All right, so before I start, it's an intermediary level introduction to AI on the edge. But I'll cover a little bit about what Couchbase is, why are we here, how we work with Google and other technologies. It's good to know there's no one literally who has heard about Couchbase before. I feel bad because I've been in this company for 2 years and it's sort of my job, so I'm doing my job really bad. But I'm based out of Sydney, so that's fine if people in Melbourne don't know what Couchbase is. Everyone in Sydney knows what Couchbase is. All right, so I have over a decade of experience as an architect, developer, consultant, and MLOps. So my primary experience was in DevOps and architecture, and then I pivoted around 5 years ago towards MLOps when I was working with a company called DataRobot, and they were building automated machine learning models based on your data. So whatever data you feed to that platform, it will give you some models. And that's where my journey started with AI and ML. And now I'm at Couchbase. So Couchbase is a multimodal data platform. It offers various different multimodalities of data. But in the slides, I'll do a brief about what Couchbase is and how it is related to AI and how Couchbase is sort of pivoting and paving the ground in terms of AI at the edge. Okay, so a few quick facts that I found on Google. So around 6 million Google searches take place every 60 seconds. Around 500 hours of videos get uploaded on YouTube. Like 100,000 tweets, hundreds of professionals join LinkedIn every 60 seconds or every minute. Now, what that basically means is we are generating a lot of data, right? And based on data, everyone is trying to get some value. So data is the new oil, as we keep coining that term. A lot of data is generated on edge devices. It could be your phones, it could be IoT sensors, smart homes, smart cars, whatever. Like literally everything is generating data these days. And with all that data, what we're trying to, at least the businesses are trying to get some value out of that data by either, looking at how their customers are behaving, or build recommendation engine. For example, when you're watching Netflix, you finish watching a series and it'll recommend you something based on your preferences or based on your historical, whatever you had watched on Netflix before. So data can give you a lot of insights, but at the same time, there are other interesting facts. 1 in 3 customers will leave the brand they love with just one bad experience. And why is that? It is because, everything is available in abundance these days, and you have a lot of choices. And when you have a lot of choices, it's very easy to shift from, one place to another. Now, a little bit more. There are around 1 billion people on LinkedIn. 140 job applications are submitted every second on LinkedIn. Domino's sells more than 3 million pizzas a day. And one more. Amadeus, it's a flight or travel aggregator website. They do 17 million operations per second with an average response of less than 2.5 milliseconds. So if you're booking a flight through Qantas, Jetstar, or Skyscanner, Kayak, or booking hotels from hotel.com, Expedia, 99% chances are you're using Amadeus behind the scenes. And why am I specifically talking about all these? It's because they all use Couchbase. So even if you're not familiar with Couchbase as a database, you might have used it when you tap your card, when you buy your coffee, because FICO is the fraud detection system. They run on Couchbase. Every time you swipe your card or tap your card, your transaction goes through FICO systems to detect whether the transaction is fraudulent or not. Every time you open a LinkedIn page or open a LinkedIn app, has anyone seen a LinkedIn app being down? Like when you put on LinkedIn and you say, oh, page not found. That doesn't happen, right? So that tells you the power of database. So, and also the power of technology, that it doesn't matter whether you know the technology, but it has touched your life in some sense. Okay, now what is Couchbase? It's important for me to emphasize on what is Couchbase because no one knows us. Okay, so Couchbase actually started as an open source project. So there were two open source projects going in parallel, CouchDB or Couch1 and Membase. Okay, how many of you guys are familiar with Redis? Oh, okay, just a handful. And Mongo? Okay, much more. Okay, so think of Couchbase as a combination of Redis and Mongo. So when these two open source projects, they were going in parallel, they thought there are synchronicity in energies, and also they can solve a common problem, which is creating a NoSQL database, but a memory-first database. So you don't have to have another layer of cache, or you don't need an additional software to improve the performance of your system. So that's how Couchbase started. So basically, these engineers joined forces and started creating a memory-first database. So performance was the key, and that's why you'll see Couchbase being used in a lot of big brands or enterprise-grade customers like LinkedIn, Tesco, Walmart, Louis Vuitton, Tommy Hilfiger, Citibank, Apple. And then what happened is a couple of years ago, Couchbase launched a product called Capella, which is our database as a service offering. And that's when we started targeting other customers as well. So it wasn't about performance, but also about availability. So with Capella, if you want to try it, it's available for free. There's one free tier available. So if you search Couchbase Capella free tier, you should be able to find it. But the idea was solving the problem, which is creating a super fast, high performant, efficient, memory-first database, but also to respect the legacy needs, keep them intact, and add them and merge them with modern requirements. So what are the legacy needs? I can give you one example, SQL queries, right? How many people are familiar with SQL queries or relational databases? A lot of you, right? And when you start using Mongo, can you use those SQL queries that you were using on Oracle or SQL Server systems before? You can't. So that was a key strength. So when Couchbase started building the platform, they decided that we're going to respect these legacy needs like ACID transaction, consistency and integrity, but also make it developer focused so they can use their existing skills. So if you're familiar with SQL queries or Oracle or SQL Server, you can bring those skills and start using Couchbase. So even though the data is stored in JSON, NoSQL format, you can still, there's an engine on top of it, which basically you run pretty much the same query as you would on Oracle or any other relational databases. Now, this is just to give you a sense of the scale. So FICO, which is the fraud detection platform, was 65% card transactions go through FICO systems for identifying using AI. The model is called Falcon, and it's a very popular model. It identifies whether your transaction is fraudulent or not. And as you might have experienced, it happens within seconds. As soon as you tap your card or use your phone to pay for something, it's pretty quick. And it is running like, thousands of rules there. So that's pretty impressive. And then Carnival cruises, if anyone has been on that cruise, they give you wearable devices. And those wearable devices actually have Couchbase embedded on them. So we are not only on cloud or on-prem, but you can use Couchbase on your mobile devices as well. And can anyone spot an Australian logo here? No? Okay. Have you guys heard about a company called Cochlear? Yeah, so Cochlear is an Australian company. They build hearing aid devices. And these are really like tiny devices, almost like earbuds. And those devices, they have Couchbase Lite embedded on them. And when a patient visits a physician and via that device, we are collecting data, how patient is responding to those devices and how we can tune those devices remotely so that patient gets the best hearing experience. And this is all done with technology through that embedded database, which is on the device. So the patient doesn't have to come and visit a physician to retune the device or do anything. The device is sending signals through what we call sync gateway or app services to your central server. And you don't have to write any custom logic to do that. And that's why we call it AI from cloud to edge or database from cloud to edge, because we got you covered on the server side where your main central server is running. And then there's a layer or there's a device, which is edge, and there's a database on the edge. And I'll talk a little bit more on that later. But now coming to today's talk track. So today's talk track is slightly focused, I should say. I'm saying slightly because it's still intermediary level conversations. But how many of you are familiar with the hype of AI or in general AI? Okay, a few of us. Okay, I think that's good that it's intermediary. Again, this is highlighting the fact that the customers have become impatient and they want best experience regardless of where they are. So I'll give you an example. Like I want my apps to just work everywhere, whether I'm in a basement where I don't get internet connection or I'm in the outbacks where I don't get internet connection. I still want them to work, right? Like, for example, if I'm using Google Maps, right, I have to download offline maps if I'm going off the grid. Otherwise, I'll be lost. But sometimes you don't do that because internet as a commodity is available pretty much everywhere. So you don't realize that unless you run into a situation where you don't have it. So the idea of the technology or the role of technology in today's day and age is to provide best customer experience regardless of where you are, and Couchbase lives by it. Okay, now, how many of you are application developers here? Okay, a lot of you. And how many of you have started working on applications from the scratch? Like you got into a job and wrote the first page of that app? Very few. I'm impressed because most of the time that I ask this question, a lot of developers get into projects that are pre-existing or some kind of changes, enhancements, but it's pretty rare. I shouldn't say rare, but there are always just a handful of people who have started working on an application or an idea right from the scratch. And if you have, you might resonate with this. So what happens is, of course, you need infrastructure, you need database layer, and then there's the application layer. Application have requirements. Requirements can be functional, non-functional, whatever you choose. And when you're beginning with that application, I think it looks really tiny. It looks like, oh, we have solved the whole problem. But as your application starts growing, you need more information. For example, if you build a retail website, right? Like now you want to know more about your customers, their behavior. So you want to do some sort of analytics. Maybe you want to offer a mobile app where customers can buy from, right? So that's another area. And then it's highly likely that, you feel like, oh, I want to give them some sort of search experience. So not only when they search for something, it results that exact text search match, but could be semantic or like matching with the meaning, right? And before you realize, the whole architecture becomes convoluted because you're using best in breed for everything, right? You want to have best experience, but then you forget that you have to manage all these softwares. You have to train your teams to use all these softwares, patching, upgrades, and the licensing cost. And this is the reality, like, I'm not joking. And it's also interesting that how every software comes in an off-cycle release. So you'll not get all your softwares upgraded in one single go. Everyone has their own release cycles. Now, how Couchbase is different, like I said, it started as a multimodal database, which is cache plus NoSQL database. But when we started working with customer and who started adopting Couchbase, they realized that, like if we can get text search, that'll be good. It should come from database. We don't need an additional software to do it. And that's how, I guess, the progression started. And then Couchbase ended up having database, cache, we have text search, we have eventing, we have analytics, mobile database, and most recently, we introduced vector database. And that vector database is on server as well as on the edge. And that is what is related to today's story. Now, Couchbase can be installed anywhere, on-prem, on any of the clouds. On Kubernetes, we have fully autonomous operator. If you're a Kubernetes fan, self-healing can be installed on laptop devices, phones, IoT sensors, etc., etc. It's a very lightweight mobile database with a footprint of 5 MBs, which is relatively easy to use and manage. Okay. All right. So before we jump into the AI conversation, let's rehearse, or let's go through some of the core definitions. So I'm pretty sure, okay, let's be honest. How many of you started getting interested in AI after ChatGPT? Okay, a few of those. I hope rest of you are honest, because 7 years ago when I was working with machine learning models, it was predominantly predictive models. And there were very few people were always interested. If I tell anyone I'm working with AI, they'll always be interested to know. But then after the release of ChatGPT, it's almost like everyone says they're working on AI, right? And everyone is, I think, if you're using ChatGPT to do your work, you're using AI, isn't it? Okay. Now, generative AI is specifically designed to generate content. And when we talk about Gen AI, we're always talking about what we call large language models, which is on the right-hand side. So these large language models, they are trained on massive amounts of data, and they have language processing capabilities. So they can make conversations, they can answer your questions. But training these large language models, it's very expensive. It's an exhaustive job. And depending upon how many parameters they're tuned for, it could take days, weeks to train these models. And as we saw before, right, the data keeps changing. There's like terabytes of data being generated every day. I think maybe petabytes. So the data is changing. You have trained your model at one point. Let's say I trained my model last month. I have trained it till last month, but data is still continuously generating, right? So your model doesn't have this new information, and the world keeps changing. And that's where vector, RAG, vector databases become important. So Gen AI, I think everyone knows ChatGPT. So I'll just stick to that example. vectors. So how many of you are familiar with vectors? Okay, cool. Then I'll not explain it. Does anyone want me to explain what vectors are? Okay, only one person. Okay, all right. So as a human being, I think I have one slide, but it's very easy for us to process in 2 dimensions, in 3 dimensions, right? So we can see maybe, for example, this screen, I can see that's 2-dimensional, 3-dimensional, projector is 3-dimensional, we see human bodies as 3-dimensional. But once we go beyond 3-dimensional, it's very difficult for us to process that information. But for computers, it's not. So vectors is basically an array of floating point numbers. So think of when we store as a human, we talk in 3 dimensions. Think of vectors, they can process thousands of dimensions. And what that means is, let's say, if I'm in a vector space and it's a sphere, I can store data in n different dimensions, right? I don't really have to think about storing it to make human understand it. It's more important for computers to understand it. And what that looks like is, I'll go through that. I'll come back to you, but hopefully that makes sense. So basically, we are just storing some mathematical floating point numbers in an array so that computers can understand it. And the reason we do that is to find the closest matches. And I'll talk about that later. And what are vector databases? So vector databases are basically storing your vectors along with the context or the data that basically represent those vectors. And where is that used? It is used when you're searching something. If you search for something, the idea is vector databases will provide you the similar information. And let's quickly go through some of the use cases that you can do with these sort of vector databases or AI. One is the content generation. So Amazon nowadays adds this line, AI generated text from customer reviews. So what they are doing is they're going through, like, let's say you look at a product and it is usually for the products that gets sold a lot. And basically what they're doing is using AI or large language models to go through the reviews and based on the reviews, create a summary. So rather than you going through all the reviews, it is doing that job for you. But again, Amazon being Amazon, I don't think we are just going to trust it because they're still going to sell the products, right? So they might just go through the positive reviews and not the negative reviews. And that's where it is very important to understand how you can benefit from AI and not just businesses and AI getting benefit from you. Data analysis and anomaly detection, this has always been the case. So AI has always been used to find anomalies. Computers have been historically better than surgeons to predict cancer based on the scans because human beings are human beings, but computers, they follow the rules. And a very important use case, and I'll do a little demo on these two, which is advanced semantics search or hybrid search. And what that means is, if you're generally speaking, when we are searching for example, in this case, if you search for blue shoes on a website, behind the scenes in the backend, you'll have to tag all your data with that blue shoes or something. Whereas when you store them in vector space, the way vectors store data is they put similar items in close proximity. So for example, if I have to take an example, I'll wait for an example. I think I have a slide for that. But if I don't, I'll explain that. And the last one is AI-powered chatbot applications. And I think anyone who has used ChatGPT, of course, knows how the chatbots are the common theme these days. A lot of retailers are using chatbots for support, for resolving support-related stuff. Uber uses it. If you have wrong delivery, they instantly let you identify what's wrong. And okay, so here we talk about vectors. So in a 3-dimensional space, especially very good example, I think. In the color, all the colors can be expressed as combination of red, blue, and green. So in this case, this is 3 dimensions. So we have 3 data points, right? And these make up a color. Now, it contains 3 values and that has 3 dimensions, but vectors can have n dimensions. And this is how they look like. They look like array of floats. So regardless of whether you're storing text, you're storing image, or you have an audio, all that information with the help of embedding models. These models are called embedding models because what they're doing is they are basically changing or they are processing the information into a mathematical array of floats. And now if you look at these floating point numbers, and when I say it can have like thousands of dimensions, that means it can store these dimensions or these vectors in multiple different spheres in plane. So this is how it will look like. Okay, and when you search for matching results, basically if you look at the dark green dot here, and if you let's say search for running shoes, in your vector space, the track shoes, the cross trainers, and the trail shoes, they are closer to the running shoes. So that's how the data gets organized. Whereas ski boots, they're far away. You'll never use your ski boots as running shoes. Thus that clarifies how vectors work, how they get stored, and when you query, when you make a query to these vectors for similar information, depending upon, we call it k nearest neighbors, whereas k is the value of how many similar values are you looking for. It's a number, it can be 1, 2, 3, 5, whatever. And if I say, give me 3 matching results close to running shoes, it'll be track shoes, cross trainer, and trail shoes. And other example could be, like cat family. So panther is a cat, tiger is a cat family, like any sort of ferals, right? So they will be residing in closed vector space, whereas dog will be further away and horse may be more further away. Now, how this works when it comes to application? So first of all, we need what we call embedding models. When you're using your application, these embedding models are basically converting your data into vector embeddings. Those vector embeddings that then get stored in what we call vector database. And the role of vector database is to store these vectors and index these vectors. Index is important for performance reasons. You want your results to be queried quickly. And then the last part is basically searching. So when you search this information, you provide how many matching results do you want, which is k. And based on that, the vector database efficiently and should provide you this information. Okay, and now comes to probably interesting part for some of you, which is how do we query that, for example, in Couchbase? So we have created our embeddings. On the left-hand side is sort of the definition of index. This is how it'll look like. And on the right-hand side, you see pretty much like a SQL query, right? So basically in your SQL query, you're writing select star from products where type is shoes, size is what, your price range. And then we are adding the vector embeddings or k nearest neighbors for the field, which is description, because most likely that's where blue shoes is coming from. But we have stored vectors and we are providing the vector range. And this vector range is coming from your query. So when you, on that application, when you searched blue shoes or blue running shoes, that's when these embeddings were created by an embedding model. And those embeddings are passed as vector to your query to search the matching results. I hope that makes sense. Okay, how does it work? So this is how the flow looks like. So there are 2 parts to it, right? So first is you have to create embeddings. And the second part is once the embeddings are stored, you're doing the search. So the first part, basically anything, it can be, text, image, audio, video, whatever. When you add that document, we are creating embeddings for those documents, right? So basically stored as JSON data, the embeddings are stored as JSON data, and then we are the data service or Couchbase data service through data change protocol creates a vector index. And Couchbase is operational database, right? So what I mean by that is now when I was talking about if your model is trained until last month, how do you provide the new information that you're getting? Now, what happens is the new information that goes to your database is captured by data service, and that data service is rebuilding your vector search indexes. So it's creating embeddings, it is refining your indexes so that the new data is available as vectors to be queried. And when your application sends a search request and gets a response, this application will get the latest response. And I will show you that. Okay, I will come to Couchbase part later. I'll give you one example. So this is a sync app, and it's a sync app because it can sync information, right? So if I tap out my phone, you can see the color of the app is changing. And this is happening through Bluetooth at the moment. I'm not using network. There's no database. If I show you, there's no database connection, but how it is related to the vector search is, I want to show you how the search results work. So what I did was, I think I should do two things here. Let me clear this image. Okay, so first example is I downloaded a picture from internet, right? And it was a picture of Apple. And when I search this Apple through my image search function, I get a perfect Apple because the picture that I downloaded from internet was looking like a perfect Apple, right? But that's not how you're going to use AI or these image models in real life. So what I did is I went to a store and I took a photo of an apple, and it looks like this. So when I search with the actual photo of an apple, the search shows matching results, which is, an apple is the closest match, but tomato also looks like apple in the picture. And then what are the other closer matches? So what it means is basically when I'm uploading the image that I was just showing, that image is converted into vectors or vector embeddings. And then a search request is sent to a database which resides on this device. So we are not sending this information back to the server for validating or to making search. All the search is happening on the device, and this is what leads to better customer experiences, right? So if every time to query a data, I'm going to the server, it might work, but if internet is good, it'll be pretty quick, but not all the time, right? So you have to think about a strategy when you're building your application. How are you going to handle your application, at the central server level, and then intermediary, maybe a sync gateway or API gateway or edge devices, outposts, whatever you use, and then eventually on your mobile side, if you are into mobile applications. And if I take this example one level down, this is another app built on similar feature, and we call it a smart card app. And what it has is basically a lens, and this lens scans pictures. So give me 1 second. I'm bringing up the product catalog, right? So, and I'll just scan the product photo, and it'll give me matching results. Now think of a device like this, put on a trolley, shopping cart in Woolies or Coles. Everyone is using self-checkout these days, but think of this. You have this scanner attached to the trolley. Whatever item you want, either you can search it through the search bar or you can scan a picture, and you can see, what's the price, where can you find this item, and you do done, add that item to the trolley, you check out, and you don't have to, go back, start scanning items once you have kept them in trolley. So basically, this is sort of the use cases you can think about, with these, especially image recognition kind of models, where you're scanning an item, putting it in a trolley, maybe do the payment on the trolley itself and have a seamless checkout experience. Okay, now let's talk about the coding part. All right, so like I said before, there are 3 parts to Couchbase. I think before I go there, I'll very quickly talk about the 3 layers that we are touching upon. So there's a central server. Like I said, like every database will be hosted somewhere, right? And then there's edge data center. So these could be, this could be edge data centers in factories, manufacturing units, and then we have edge devices, which is basically your end user devices. And you have to think about solving the problem on all these different layers. So centralized architecture will not work if internet goes away, right? And that's where you might rely on edge data centers. But what if edge data centers aren't available as well? And that's where it's important to have that information or have that flexibility or an option within your devices to run your application. But at the same time, it's important to have this information on the devices is because there could be sensitive information you don't want to send to the central server, at least not through internet. And that's where it becomes important to process your data on the edge. And that is where the AI on the edge becomes even more important. And how do we do it? So first of all, I have this Kotlin CB-like setup. And what am I doing here is basically initiating my database. So that's the first phase. Oh, let me explain the demo first. So what I am doing here is I have created a chatbot. Let me close this one. Too much information. Okay, so I've created this chatbot which you can ask any questions. And the idea here is you upload your document, a PDF document, and you can basically augment the information that your machine learning model already has. And the steps are initiating the database and then doing a little bit of PDF reading. And how we are reading the PDF, we are doing that with the help of chunking and space splitters. So basically, the PDF is being read through this code here, and then those chunks are stored in vector database along with the actual text. And if I go back to the slide to show you what that looks like is this page here. So RAG, very important when it comes to leveraging on LLMs with the latest, more accurate answers. So if I have to draw parallels with ChatGPT, a year ago, ChatGPT, when you ask for any latest information, it might give you an answer that I've been trained only on data until September 2021. But more recently, what they have done is they have implemented RAG, which is retrieval augmented generation. And ChatGPT is running over internet, so you might not use your proprietary data with ChatGPT, but the idea remains the same. So there are 3 parts to it: pre-query work, RAG, and then final results. And RAG is a 3-word phase itself, which is retrieval augmented generation, right? So if you ask a general question to the model that you have trained last month, you will be able to get an answer, right? But how can you make it more accurate with the latest information that you have received after last month? That's the augmentation part. And how do you do that? Is by storing that data as vectors like we did. So what we are doing is in my demo, what I'll do is I'll basically upload a PDF document. So if I go here and go to PDF, I was looking, what should I look for? And I found there are some documents that REA group have uploaded with the property history and property results. And what I did is I downloaded that document from internet, and now it's chunking that document. I think I uploaded the wrong document. I wasn't hoping to upload a big document like this one, but it's fine. It's usually fast, so I'm not too worried. And then I go here and I ask for, okay, so what kind of properties are affordable? It's a very vague question, but let's see what answers it come up with. Okay, so it says that the provided text doesn't explicitly state what types of properties are more affordable, but it mentions that housing demand remains resilient and smaller dwellings in capital cities are probably less expensive. And if I scroll down, you can see context. And what am I doing here is, so the results are eventually coming from the large language model that has been trained last month, but the context is basically the information that was there in this PDF document. So along with the information that LLM already has, I'm giving it additional context based on the latest information, which helps this large language model to give you more accurate and recent results. And very quickly, how that looks in code is, I did have it in slides as well. I just have 2 minutes left, so I'll be very quick. So basically, you initiated the database and then you send the vector search query. And in this vector search, you're basically passing your vector, and your vector is coming from the embeddings created on the query. And once you do that, there are 2 steps here, right? So that either you can use Google Gemini API to make the query, if it is cloud hosted model. And in this example, we are using Gemini 1.5 Flash. You get the results from Gemini, but these results will be along with the recent information that we have passed to the model. And we can also combine vector search with the large language model generated responses, right? So the information is always latest. But you can also do a local model. So in this example, what I've done is I have downloaded a Gemma model and I'm making these results locally. So the image search demo that I was showing was first one is Gemma model. The second one was Apple Vision model. And the PDF document that we saw with past responses, that was Google Gemini API. And I don't have any time left, so I wouldn't go through other details, but yeah, feel free to connect to me. I'll be available on Booth for a few more hours. And yeah, if you have any questions, let me know. Add me on LinkedIn, reach out. Happy to have a discussion. Thank you very much, everyone.